Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to find the gradient and the tangent to a curve. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. What is a tangent? A tangent is a straight line, just touch a curve at a particular point. Here is a curve. So let's say a point anywhere along the curve. So let's say this is point Px, and the tangent to the curve at Px will be like this. So therefore, in order to find the equations of the tangent, we know that the equation of this tangent is y is equal to mx plus c. If we have a line that cut through the curve twice, so remember that, so this will not be a tangent to the curve. So tangent to the curve is only touch the curve once, okay? Just remember that for me, okay? So this will be the tangent, okay? And this not a tangent, so keep that in mind for me. So to work out the equation of the tangent, we follow 3 steps. Now, step number 1 is we need to find the point first. That is P, X, and Y, okay? And then second step is we need to find the gradient. That's the second step. To find the gradient, we can differentiate the functions, and then we substitute the point in, okay? That will give us the gradient. Now, the third step is we use y is equal to mx plus c, or we can use y minus y1 is equal to m bracket x minus x1. So we can use either one of them to find the equations of the tangent. So let's just go through a couple examples. First one, for the curve y is equal to 2x power 3 plus x squared minus 5x plus 3, find the gradient to the tangent to the curve at point -1, 7. So first of all, let me just write down the equations of the function first. So y is equal to x to the power 3 plus x squared minus 5x plus 3. So this is the functions. So we need to find the gradient of the function first. The gradient is the differentiations of the functions. So that is dy dx. So let me find dy dx first. So dy dx, remember y is equal to x to the power n. To differentiate this, so dy dx is equal to, we'll bring the n down, so n, x, and then we less 1, n minus 1. Okay, keep that in mind. So therefore, the 3 will bring it down, so it becomes 2 times 3, so which is 6. So 6x, and 3 minus 1 give me 2. So there you go. Then the 2 will bring it down, and we less 1, so become 1. So plus 2x, so 2 minus 1 is 1, so x power 1. So x power 1 is x, so I just leave that, okay? And then this is 1, bring it down, so 1 times -5 is -5 or minus 5. And x power 0, because 1 minus 1 is 0. So therefore, anything power 0 is 1. And then the 3, differentiate 3, a constant, give me 0. So this is the gradient functions. So therefore, to work out the gradient at point -1, 7, so at -1, 7, so this means that x is -1. So therefore, to find the gradient at x equal -1, so this is replaced with -1. Because every time we see x, we replace with -1. So that will give me, so dy dx will give me 6 lots of -1 squared plus 2 lots of -1 minus 5. So that will give me 6 minus 2 minus 5. So 6 minus 7 give me -1. Otherwise, you can just put that on a calculator. So this means that the gradient is -1 at point -1, 7. So therefore, the gradient of the curve at point -1, 7 is -1. So there you go. Second one, find the equations of the tangent to the curve f of x is equal to 2x bracket 3 minus x at x is equal to 1. Now remember, to find the equation of the tangent to the curve, we follow 3 steps. So step number 1, we need to find the point first. So the point is So when x equal 1, we need to find the point x and y, okay? So when x is 1, so we need to find the value of y first. So when x is equal to 1, we need to find y value. So that means f of 1. So therefore, every time we see x, we replace with 1. Okay, so keep that in mind. So now I just go 2 lots of 1 and then 3 minus 1. So this will give me 2 times 1 is 2 and then 3 minus 1 is 2. So that will give me 4. Otherwise, you can just put that on a calculator and you should get 4. So therefore, the point is 1, 4. So let me just write it on here. So that is step number 1. We find the point, right? And second step is we need to find the gradient. Now to find the gradient at point 1, 4, so we need to differentiate the function first. That will give us the gradient of the functions at any point. Then we substitute x equal 1. We'll find the gradient at x equal 1. Okay, so keep that in mind. So let me just write down the function first. The functions is f of x is equal to 2x 3 minus x. To differentiate this, I can use product rules. Otherwise, I can also expand the brackets out and differentiate. So let's just do it. So we expand this first. So that will give me 6x and 2x times negative x. So that give me minus 2x squared. So that is the functions. Okay, so now we differentiate to find the gradient of the function. So f dash x will give me, so 6 minus, so 4x. So that is the gradient functions. But we want to find the gradient at x is equal 1 or at point 1, 4. Okay, if you like. So let me just move this up. So at point 1, 4, so the gradient is, so f dash 1 because x is equal to 1. So every time we see x, we will replace with 1. Just keep that in mind because we want to find the gradient at x equal 1. So that will give me 6 minus 4 lots of 1. So 4 lots of 1 is 4. So 6 minus 4 is 2. So therefore, the gradient at point 1, 4 is 2. So now we already find the second step. So the gradient is equal to 2. Now for step number 3, we can either use, let me just write step number 3. We can write y is equal to mx plus c. We can use these equations to sort out the value of c because we already find m. Or we can use this equation here. Y minus y1 is equal to mx minus x1. And we know that this is x1 and this is y1. So let's use both rules to find out whether we have the same answer or not, okay? So first of all, let's use y equal mx plus c. So let me use y equal mx plus c. And we know that the gradient m is equal to 2. So therefore, y is equal to 2x plus c. And we also know the point that is 1, 4. So this means that when x is 1, y is equal to 4. So I just substitute that in. So 4 is equal to 2 lots of x is 1. And we add c. So that means 4 is equal to 2 times 1 is 2. We add c. And I just move the number 2 on this side. So it becomes minus. So 4 minus 2 is 2. So that becomes c. So therefore, we know that c is equal to 2. So now the equation of the tangent is y is equal to 2x plus 2. So let's use y minus y1 is equal to m x minus x1. See if we get the same answer, okay? So all y minus y1 is m x minus x1. And we know that the point is 1, 4. And the gradient is 2. So y minus, now don't forget, okay, this is x1, this is y1. So y1 is 4. So there you go. M is 2, which is put 2 there. X minus x1, which is 1. So now what I do, I just expand the brackets, okay? So that becomes y minus 4 is equal to, we expand this bracket, so become 2x, and we expand this bracket minus 2. So now what I do, I move this negative 4 on this side. So that become positive. So that means y will give me 2x minus 2 plus 4. So minus 2 plus 4 will give me 2. So that means 2x plus 2. So there you go. So this is y is equal to 2x plus 2, exactly same as this. So therefore, you can either use y equal mx plus c or using this rule, okay, to find the equations of the tangent to the curve, okay. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into this. So remember, step number 1, we need to find the point. So step number 1, the point we already have here. So 2, 4. So we don't need to find it. But the second step is we need to find the gradient, okay? Now to find the gradient, so we know that the functions is this. So what we need to do is we need to find the gradient function first. Then we substitute the point 2, 4 into the gradient functions. That will give us the gradient at point 2, 4. So let me just differentiate this. So let me just write the function down first. So 2 plus 3x minus x squared. So to differentiate this, I can just write dy dx will give me, differentiate 2, give me 0, and differentiate 3x will give me 3. And negative x squared become minus 2x. So this is the gradient functions. But we want to find the gradient at point 2, 4. So this means that when x is equal to 2, we substitute this 2 here, okay? So therefore, the gradient is equal to 3 minus 2x, but x is 2. So we just put 2 there, and 2 times 2 is 4. 3 minus 4 is negative 1. So there you go. So therefore, the gradient at 2, 4 will give me negative 1. So we found this now, negative 1. And step number 3, we can use either y is equal to mx plus c or y1 minus y2 is equal to mx minus x1. So let's just use that. So y minus y1 is equal to mx minus x1. So now we just use that rule to work it out. So we already have m, so that is negative 1. And we have the point, that is this. So now I just use this formula. So I just move this up a bit. So y minus y1 equal m x minus x1. So now x1 and y1 is 2, 4. So y minus, so y1, this is y1 and this is x1. Don't forget. So y1 is 4 is equal to m is negative 1, and x minus x1. And x1 is 2, so which is minus 2. So now what I do, I just expand the brackets. So that becomes y minus 4 is equal to negative 1 times x is negative x. Negative 1 times negative 2, which is positive 2 or plus 2 if you like. So what I do now is I just move this on that side. So that will give me positive. So plus, okay, if you like. So therefore, y is equal to negative x plus 2 plus 4. So 2 plus 4 is 6. So I can just quickly write plus 6. So there you go. I hope you got it correct. And thank you so much for watching. Bye.